power. So let's listen to his presentation about mesenchymal stem cells.
Good morning and thank you for the organizers to give me a chance to be here with you to present about the new horizon for the drug. A special thanks for the organizers for one reason. If you see, the science is dynamic. Every day we find change coming in regenerative medicine or any science. Overall, is to talk about the basics of science in regenerative medicine. Today, we are talking a lot of applications, clinical trials, and we are talking about science where we can think of how do we standardize this drug with a standard drug. See, the changes which are coming are so dynamic. We need to understand why this new drug we require. Do we really require when the standard procedures of science are working well? Pharmacodynamics is giving us a lot of chemical molecules. But at the end of the year, when we find many of the drug molecules which are researched out from a conventional method, they fail in treating many of the diseases. If you see my background, I'm a pure clinician. By training, I'm a neurosurgeon. During the practice of my 10 years, I did definitely notice there are a lot of incidences where I could say patients, we cannot help you. That is where it pinches as a physician. Like chronic debilitating conditions are there, cancer is there, autoimmune diseases are there, aging diseases are there. We, at the end of the day, we say, yes, nothing can be done. This is where we look for something new. I believe we start searching what else we can do. Now, in this situation, I'm going to put in subsequent slides a hypothesis to you. Why do we require a new molecule? And I'm going to talk today to you about the very important change paradigm in the sciences. That is a living drug. The living drug is a concept of understanding. When we talk of a living drug, there should be a non-living drug. A non-living drug is a pharmacological molecule which we practice as on did as a conventional model in the treatment. When we talk as a living drug, means I'm talking as anything which is living, breathing entity. But it works as a molecule for therapy. Sorry. And this living drug which I'm going to talk to you is a stem cell. Probably we all talk of stem cells. If you happen to see yesterday, today, in most of the sessions, stem cell is a topic which is spoken in the conferences annually which are conducted for regenerative medicine as well. This is a topic in most of the conferences. If you take with any other subject like orthopedic, gynec, medicine, one or other two talks linger around stem cells or regenerative medicine. This speaks how fast people are looking for a change, where the current system is failing. Being a clinician, I'm not going to talk more scientific words, but a clinical application, why we need new horizon drug. If you see, if we don't see for a change of this kind of molecule, whatever we do, at the end of the day, we end up saying there's a lot of conditions, more than 150 conditions, or maybe thousands of genetic conditions we include, where we cannot do anything. There we fail by saying, yes, we are helpless for you. When we see for a new molecule like MSC as a drug, then there are a lot of possibilities of manufacturing these cells, and there are a lot of challenges and barriers So we have to see what are those challenges and what are those barriers which can be functionally important to bring this as a standard of drug. What is this living drug? As I said, it's a living, breathing entity. Now, when we talk of stem cell, have you ever thought of where do they stay, what do they do, where do they come from, what are their jobs? We just speak of them modifying or giving them as a kind of molecule. But why they are specifically sitting at some areas of the body? What are they doing there? What is the area, what we call the niche of the stem cell? What is the area? What is happening there? What is responsible for them to make our wear and tear and healing? What you can say? Homeostasis of our body maintaining. These are microscopic basic potentials of our body doing their own business and jobs in our body. This is very important. When I talk, they do a specialized job in the body. You can see when we talk of any organ, whether take a liver, hepatocytes do specialized function of liver only playing along our metabolism in the liver. Neurons in the brain, very specialized jobs they are doing, their business are doing. We can't ask neuron to do a job of liver. Hepatocyte can never do a job of neuron. So there are very specialized functional units which are working as per the requirement of the body. As I spoke you about limitations of the current system, the pharma molecule is a molecule which is made of a chemical as a one drug, one action. This action has got its own limitation and it doesn't make anything other than the specific action. That too, at the end, it may represent a toxicity or a side effect. Many of the conditions which I spoke just now, where you find at the end, instead of treating a disease, drug represents with its toxicity. The change of drug, when we see an umbrella of regenerative medicine, it is a broad spectrum which covers allogenic, autologous, iPSCs, cytokine bioactive factors, tissue engineering, and what not everything comes into this factor. I was just speaking you just 2 minutes before about the hypothesis. This is very important for me to elaborate this hypothesis. This hypothesis speaks that as a functional unit of our body, as I was talking to you, these cells, stem cells, they are functionally present in niche of every organ. Every organ has a niche. Niche is composed a niche cell and a cell which assists it, which gives the signals with the ECM around what cell has to do depending on the body requirement, which gives the signal to them, and they differentiate by symmetrical or asymmetrical division. Symmetrical division creates a pull, whereas asymmetrical division creates a differentiation and maintains the wear and tear of the body or that organ and ultimately of the body. This hemostasis exists till each cell of the body is at hemostasis. It means that there is a functional stability between the cells and ECM, which gives a normal function. Now, deregulation of any kind in this function of a cell, whether it's a qualitative or quantitative, will lead to a disease state where the body is not at ease. This is very important. When body goes at unease, it speaks that there's a problem. Something has gone wrong in the function of a cell or the ECM or function or tissue around the cell or ECM around the cell.